Okay. Yeah, we're going to talk about the AI tool for speech analysis. Since we all struggle with a shortage of healthcare personnel, new technologies are necessary to be able to keep a high care standard in the future. As just has been mentioned, AI is a new technology that's being used more and more since it has promising results in healthcare. This is also the fact in the area of speech. So there are many applications for AI in speech, like speech recognition, for example, analyzing a conversation and making a summary that's putting automatically into the text in the computer. It's also being used for diagnosing mental illnesses, where a speech analysis of the conversation can say what mental illness the patient is suffering from. So since it has high potential, we also see that for the specific use case where we want to use it in, and that's for speech analysis in cleft patients. So looking at the treatment of clefts, we see that there's still a large variety in treatment protocols. And there's a main problem with the consensus on the cleft palate closure. There's still discussion what would be the best timing, should we do it in 1 or 2 stages, what techniques are the best to use. And speech is one of the most important outcome measures to assess this. So a good speech outcome assessment is essential to know which protocol gives the best results. So within the ERN, we're working together and we're looking at establishing a registry to collect all outcome measures. And for speech, we had a separate meeting with more than 20 experts, and it was done in January of this year. And we wanted to ask to answer some questions. One of them was, for whom are we measuring? And we all agreed that patients should be the focus of the attention in the registry. So we're doing it to make care better for them. The second question was, what do we actually want to measure? So that was speech intelligibility, velopharyngeal function, and articulation. That were the key features that we want to measure as an outcome. And what tools do we have available? And that are patient-reported outcomes, like some scales of the cleft Q, but also the ICS, and outcome measures like the PCC and the VPC sum. During this meeting, we also saw that we still have a lot of challenges we need to tackle. And one is that there is no standardized protocol for audio-video assessment across centers. That means that some do audio assessment, some video recording, some do immediately the assessment live with the patients, and others do it afterwards based on the video or audio imaging. So this could influence also outcome. Secondly, there was no objective tool to assess the nasality in patients. So the nasometer is being used, but it's out of production now. So that's also a problem. But all the measurements we have are really subjective. It's also clear that there's an international shortage of speech and language pathologists. That's more in some countries than other countries. And that's also giving some challenges. And the other thing is already something that's going on for a long time, that we would really like to do a good comparison between languages, and that's still a big challenge. So ideally, we would like automated analysis of hypernasality of speech, and to do that in recordings in multiple languages. So that would be our goal. And this will provide us with a tool for objective outcome evaluation of the treatment. And that way we can optimize the care by adjusting some of the protocols. It can also be used as a screening tool if there is a shortage of SLPs, and sometimes people have to wait a long time before they can have an assessment or before they can start treatment, and this could maybe aid that they could start a little bit earlier. So as mentioned before, the technology we are using for this is AI. But yeah, AI, what is it? So we just had a nice explanation already from Professor Cahill, but often terminology is a little bit mixed. So we just want to give a short overview, short explanation. So we want to create this automated speech analysis, and we want to do that with artificial intelligence. And artificial intelligence is the science devoted to make machines think like humans. And within artificial intelligence, we saw a lot of examples, but we want to use machine learning. And machine learning is a type of IA that focuses on enabling computers to perform tasks independently and improve with experience. So within machine learning, you have different types of algorithms, and deep learning was mentioned before, but there is also, for example, non-deep learning. And we want to explain you a little bit the difference. So the most recent and advanced type is the deep learning, and it's more complex because it uses multiple layers of interconnected nodes to detect the patterns in data. So it works a little bit like the human brain. It mimics the neural network of the human brain. On the other hand, there's non-deep learning, and that has been traditionally used for hypercausality detection tools. And the difference is that it's a more linear algorithm. So it's mainly comparing the data that you put in to the sample data. So the main difference between deep learning and non-deep learning is the way you process the input. So in deep learning, you can just put it in. And in non-deep learning, it requires a pre-processing step of the data you put in to select and extract the features from the data.
Yeah, so Sarah is talking about features. So let's go a little bit deeper, or for the Irish among us, let's go a wee bit deeper. Because in our case, we're talking about speech features that we can extract from our speech samples. And those features can be best explained by the source filter model for speech production. And well, this model poses that you have a source of sound, which are our vocal cords, and that our vocal tract filters out some of those sounds, and that actually produces our speech. And based on this model, we can categorize these features into 4 categories, and we're not going over them all. But just to show you that there are a lot of features that have been well studied even before artificial intelligence was invented, that we can use to analyze and even better understand speech disorders. So we've talked about artificial intelligence, machine learning, the speech features, but how are we eventually going to develop such an automated speech analysis tool? So the process can globally be subdivided in 3 phases. And in the first phase, you have to prepare your data, which is quite a step, which is why I put it separately in here. Then the second phase involves developing your artificial intelligence model and see how it works. And then only in the last step, if it works, you can validate your model and hopefully eventually implement your model in practice. But let's start with the first phase, because that first phase, preparation, may even be the longest phase. Because it requires you to anonymize and clean the speech samples, cut out parts of the speech samples that are not relevant for the assessment, and also prepare the speech samples for your model. And that's what we've talked about before. You need to either extract features from the data with the non-deep learning models, which we call feature dependent, or you can directly give your speech recordings to the model, which we then call feature independent. And what we haven't said before is that the feature dependent models, which require those pre-processing steps and have a little bit of a higher workload, the advantage of those models is that you do require somewhat less speech samples to obtain the same accuracy. And besides those speech samples and all the speech data, you also, of course, have to prepare your data set that includes your speech assessments and other factors that may be predictive for the speech disorder. So think about the age of the patient, think about the gender of the patient, and all other relevant things. So once you're done with your data set, you've sorted it all out, then you can develop the model. And like we also said before, is you can choose between the deep learning models and the non-deep learning models. And once you have that model, you're going to evaluate it on its performance. And this is mostly expressed in what we call concordance, which is the correspondence between the evaluations by your artificial intelligence model with the evaluations by your expert, your speech language pathologist. And so far in literature, concordances of between 80 to even 98% have been reported. So, yeah, that gives us a lot of hope that we can eventually do this in the future in practice. And this is also the phase where you can adjust your model a little bit if it does not work how you want it to work. So then, if you have prepared your data set, you have developed your model, only then you can start to validate your model. And you do that on an independent data set. So speech samples from another center, or even speech samples in another language to see whether the same model also is applicable to German patients, to Scandinavian patients. And only if you have validated your model, then you can implement it in practice, hopefully, or for research. So those are our current plans, our current project. But we also want to do a lot more in the future because, as I touched upon already, we want to break those language barriers. We would like to develop artificial intelligence models that could be used all over Europe or even all over the world, so that speech is assessed according to the same methods for every patient, so we can compare those results. And besides breaking those language barriers, we would also like to assess other aspects of speech. So the speech intelligibility and also articulation. And currently we're using audio recordings so far, but what we also want to do in the future is explore what the added value is of video recordings to see whether that adds some predictive value to our model. And what we also would love to do in the future is to extend this model beyond only patients with a cleft, but also for patients with other craniofacial anomalies and even just patients without craniofacial anomalies, but with other speech disorders such as stuttering or other things. So currently we have obtained some funding already for our project. That's why we are already very busy with it. But we would love to collaborate in the future. So if you're interested in it and you would like to collaborate with us, then please contact us. Thank you.